All right, let's go through this. So, number 1 and 2, and actually 3 and 4 as well. We got to follow Pemdas, right? I told you guys that yesterday, Pemdas.
Yep.
So what does the P in Pemdas stand for? Parentheses. So let's solve what's inside these parentheses first. 6 minus 3 gives us 3. 4 plus 2 gives us 6. We still have those exponents attached and a plus sign in the middle. What does the E in Pemdas stand for? Exponents, right? So now let's evaluate these exponents. 3 squared is just 3 times 3, which is 9. And 6 squared is 6 times 6, which is 36. There's nothing to multiply or divide. What does the A in Pemdas stand for? Addition. So let's go ahead and add 9 plus 36, giving us 45. Same thing with number 2. 10 minus 8 is 2. Keep that third power. And then what's negative 4 plus 5?
Negative 4 plus 5 is negative 1.
Positive 1. Because if we have if we start at negative 4 on the number line and we move 5 spaces to the right, we land at positive 1. And we got to square that as well. 2 to the third power is 2 times 2 times 2. That gives us 8. And 1 squared is just 1 times 1. That's going to be 1. 8 plus 1 gives us 9. Close it. Close your Chromebooks, please, if you have it open. Okay, number 3. Again, we're going to solve what's inside the parentheses first. 3 times 4 gives us 12 squared. That's just 12 times 12, which is 144. 5 times 2 gives us 10. To the third power is 1,000. Okay. How are we feeling on those 4? Thumbs up, down, sideways? Hopefully we're feeling pretty good. Yep. Good. All right. Number 5. This is going to be the product rule, so 2.1b. I'm going to put which notes each of these questions is from, just in case you want to reference them. And with the product rule, whether we have 2 like bases or 3 or 10, it doesn't matter. All we're going to do is keep our base the same and add the exponents. 2 plus 8 plus 1. We can't forget about the 1 on our x right there. Okay, because when we add that together, it changes our exponent, and we get x to the 11th power. If you got x to the 10th, you were very, very close. You probably just forgot about this x to the 1st right here. Okay, so x to the 11th is the answer to that one. Number 6, that's also product rule, and number 6 is a little bit confusing because we've got 2 variables going on, right? Well, like we saw in number 5, we can only combine them if they had the same letter, right? We got all 3 x's. We can combine those into one x. But here we have 2 y's and 2 z's. So we're still going to combine like terms using the product rule, but we have to be careful about which terms we're combining. We have to combine the y's, and we have to combine the z's, but we have to do it separately. So y to the 6 plus 2 times z to the 3 plus 1 gives us y to the 8th, z to the 4th. And that's all we can do. We can't combine those 2 terms. They're different variables, right? So our answer is just that. Y to the 8th, z to the 4th. Number 7 is also the product rule, but because we have numbers as bases here, I saw a lot of people get 49 to the 15th power, which is totally justifiable. I get why you would do that. We'll see that in number 8. But in number 7, the 7s are our bases. They're not our coefficients. So we have to keep 7 the same and add our exponents like that. Negative 20 plus 25 gives us positive 5.
It's 30.
Is it 35? Yeah, it's 35 and 15. My bad. It sounded wrong even when I said it. I was like, that doesn't sound right, but thank you for catching that. Now with number 8, is 3 our base or is A our base? A is our base, right? 3 is just the coefficient for our base. So what we're going to do is, just like with number 6, we're going to group up what we can combine. We can combine 3 times 6. And we can combine a to the negative 5th times a to the 7th. Three times 6 out in front. That's going to be our new coefficient. Times a to the negative 5 plus 7. Product rule. And this is 2.1e. No. Yes. 2.1e power of a product. This one was 2.1b. Again. So 3 times 6 gives us 18. Negative 5 plus 7 gives us 2. 18a to the 2nd is our answer. I know I didn't give you red pens. Just make the corrections in pencil. Number 9, this is going to be 2.1 C, the quotient rule. We've got like bases being divided. B on top, B on the bottom. All we have to do is subtract downward. 24 minus 12. And that's going to give us b to the 12th. I saw a lot of people with b squared as their answer, b to the 2nd. Again, I totally understand. You probably just divided 24 by 12 instead of subtracting. So make that change if you need to, so that you know we're going to be subtracting downward. Number 10, we've got x to the 8th over x to the 4th times x to the negative 2nd. Just like in our warm-up, we've got to solve the product rule first. 4 plus negative 2 is x squared. Oops. And then we have that underneath x to the 8th, right? So our first step was getting the product rule done. 2.1b slash c. We got our product rule done. Now we have to do our quotient rule. X to the 8 minus 2, which is x to the 6th. Questions so far? First 10. Beautiful. If you do have a question, feel free to interrupt me. Number 11, add the exponents on the top. You get e to the 2nd over e to the 7th. Number 11, we're going to have to use 2.1 A, B, and C. So we used B to get these numerators together. Now we got to use C to subtract downward, giving us e to the negative 5th. And we don't want to leave that as e to the negative 5th, right? We want to put it over 1, flip the fraction around, and make our exponent positive. 1 over e to the 5th. Number 12 looks similar, but we've got something a little bit different. Now we've got an H down here too. Uh-oh. Well, let's go ahead and instead of doing the product rule, because we can't, they're not like bases, they're different letters. Instead, let's go ahead and expand out our numerator and our denominator and see if there's anything we can cancel out. Again, this is going to give us the best idea of what we need to do. So we've got how many pairs of G's to cancel on the top and bottom? 3 pairs, right? 1, 2, 3. Gone, gone, gone. All we're left with in our denominator is G squared H. All we did was bring those G's back together and make it G squared times H. And then it looks like we canceled everything out on the top. So what's going to be our numerator?
1.
1. If everything cancels out, there's still a 1 left over, not a 0. Can't just get rid of the fraction. You have to have 1 in the numerator. Questions on 11 and 12? Perfect. All right, 13, we got 25 to the 0th power. What's anything to the power of 0 equal to? 1. Nice and easy. Number 14, we've got 4 to the negative 3rd power. We're going to put this over 1, flip it around, and make our exponent positive. You can leave it as 1 over 4 to the 3rd. If you want to evaluate it into 1 over 64, that's fine too. I'll accept either one. The important part is flipping and having that 1 in the numerator. Number 15, we've got, oh, and these were both 2.1a, sorry. Number 15, this is going to be 2.1d, the power rule, right? So when we see an exponent on the outside of our parentheses like that, what are we going to do with these two exponents? We're going to add them, subtract them. What are we going to do? We got to divide them. We got to multiply them, right? Whenever there's an exponent outside the parentheses, we have to multiply it. 4 times 0, giving us y to the 0, and anything to the power of 0 is once again equal to 1. Yes, you could have skipped that whole process and seen that, oh, this whole thing is being raised to the 0, so the whole thing has to be 1. You could do that too. I know this isn't the most exciting thing to talk about. I appreciate your guys' focus. Hopefully this is helping solidify these concepts before tomorrow. So 16, we got a little two-parter. We need 2.1d and 2.1b. We got to solve this power rule first. X to the 5 times 3. That gives us x to the 15th, right? Times x to the negative 7th. Now we have to use the product rule and add our exponents. We get x to the 8th power. (17) is another one that tries to trick you into dividing 24 divided by 3 and getting 8 to the 8th power. Very close, but again, we have to subtract our exponents. 8 to the 24 minus 3 gives us 8 to the 21st. If you got 8 to the 8th, I totally understand why you would think that. We just got to remember to subtract. Number 18, y to the 4th raised to the 0. Hello, we see a 0 exponent. What's this first part of the problem equal to? 1, right? So now we just have 1 times y to the 3rd. Well, that just equals y to the 3rd. Any questions on exponents before we start talking about scientific notation? Okay, now let's write some numbers in scientific notation. We've got 1,500,000 over here. Hold on one sec, sorry. Okay. So we got 1,500,000. Okay, our decimals here at the end. And we want it to end up wherever there's going to be just one number to the left of our decimal, right? So we want it to end up right there. We're going to move it 1, 2, 3, 4, 5, 6 spaces. 6 spaces means our answer is going to be 1.5 times 10 to the 6th. Are you sure it's not negative 6?
Yes.
Well, how are you sure? How do you know?
It's big.
Because it's a really, really big number. Exactly. So we're going to have a positive exponent. Great job. Number 20, is this one really big or really small? Really small. So what's our sign going to be on our exponent? It's going to be negative, right? 1, 2, 3, 4 spaces gives us 7.8 times 10 to the negative 4th. Now we got to write in standard notation, 6.7. How many spaces do we want to move this decimal? 6 spaces, right? We can tell by our exponent. Are we going to move this decimal to the left or the right, though? We're going to move it to the right. We have a positive exponent. This is a really big number. We've got to make it bigger. 1, 2, 3, 4, 5, 6. Fill in the zeros. And you get 6,700,000. Okay, if you got 67 million, you probably just threw 6 zeros on the end, but we got to keep in mind this 7 here takes up one of those spaces, right? Then we got 2.5 times 10 to the negative 4. Negative 4 says we got a small number. Let's move this to the left. 1, 2, 3, 4. Fill in the spaces. 0.00025. And finally, let's do some operations on these scientific notation numbers. So we got 3.4 times 5. We're going to go ahead and take out just those numbers first, and we're going to multiply them. We get 17.0. Now we can take our powers of 10 and do the product rule. We get 10 to the 8th. Put our two numbers together, 17.0 times 10 to the 8th. Is that our final answer? No, why not? What's wrong with it? The 8? Yeah. And also, the 17, that's way too big, right? We can't have a 2-digit number as our leading number. So let's go ahead and move this decimal 1 space. And what do we have to do to 8 when we move that decimal 1 space? We're going to add 1. Multiplying, addition. Always put those two concepts together. For multiplying numbers in scientific notation, we've got to add 1, and we have to add their exponents. 1.7 times 10 to the 9th. Questions on multiplying? You got a question? Okay. Number 24, same thing. We're going to take our numbers out in front, focus on those first. 5 goes into 42 8 times. 2, bring down the 5 times. So now our leading number that we get is 0.85. We'll have to come back to that. Let's take our powers of 10. 10 to the 8th over 10 to the 4th. We're going to subtract downward. That's the quotient rule. This is 2.3b. Ten to the a minus 4 gives us 10 to the 4th, right? So we got 0.85 times 10 to the 4th. And again, we do not have the notation that we want. We can't leave our answer like this. We have to move our decimal one space. And what are we going to do with 4? Are we going to add 1?
No, we're going to put minus 1.
We're going to subtract 1, exactly. 8.5 times 10 to the 3rd power.
Now what do we have to do?
Great question.